welcome back. I'm glad you've returned to the silence. We leave the familiar behind to witness the silent beauty of the cosmos as we begin our long, drifting journey toward the vast, ancient ring of debris known as the Asteroid Belt. This sprawling ring of cosmic stones rests quietly between the orbits of Mars and Jupiter, acting as a profound boundary line in our solar system. Here, millions of rocky remnants float in an eternal dance, preserving the raw materials from the very birth of our planetary neighborhood. When we look at this region, we are not looking at the aftermath of a destroyed world, but rather at the preserved pieces of a puzzle that never came together. It is a place where time seems to stand still, where ancient fragments of rock, metal, and ice whisper secrets of a time 4 billion years ago. As we drift closer, the crowded chaos often depicted in fiction fades away, replaced by an immense, serene emptiness where individual worlds are separated by hundreds of thousands of miles of quiet space. At the heart of this silent realm floats Ceres, a small and mysterious world that holds the title of the only dwarf planet in the inner solar system. Ceres is a sphere of rock and ice, a quiet queen ruling over a kingdom of scattered fragments. For centuries, astronomers wondered why this massive collection of material never gathered itself into a single, majestic planet. The answer lies in the immense gravitational reach of giant Jupiter, whose massive presence constantly stirred the cosmic soup, preventing these fragments from ever bonding completely. The gravity of the gas giant acted like an invisible hand, constantly pulling and shaking the region, leaving a beautiful failure of planetary creation. Instead of one grand world, we are left with a magnificent, fractured tapestry of thousands of smaller stories. Among these ancient travelers are remnants of iron and nickel, heavy metallic cores of shattered protoplanets that hint at a violent and chaotic past. Some of these asteroids, like Psyche, are completely metallic, shining silently in the dark as exposed hearts of ancient worlds that were torn apart before they could fully grow. Others are simple piles of rubble, held together loosely by nothing more than their own weak gravity, drifting through the dark like cosmic dust. The diversity found within this belt tells a story of intense collisions, slow accumulation, and the eternal balance of celestial forces. As we begin to explore these individual pieces of history, we find ourselves looking into a mirror of our own origins, seeing the raw elements that built the planet beneath our feet. Let us now drift deeper into this ocean of stone, listening to the quiet cadence of the asteroid belt. The journey brings us to a specific zone in the dark, a vast expanse lying roughly between 2 and 3 times the distance from Earth to the Sun. In this region of the solar system, the warmth of our star begins to fade into a gentle, cool glow, casting long shadows across the floating stones. This cosmic highway serves as a grand borderland, separating the rocky inner planets from the massive gas giants that rule the outer realms. As we drift through this quiet territory, we realize how perfectly balanced these objects are in their orbits, caught in an eternal tug of war between the Sun and the outer giants. It is a place of profound isolation, where the geometry of the solar system unfolds in a slow, rhythmic dance across billions of miles of empty space. There is a common misconception that this region is a dense and chaotic minefield of colliding rocks, but the reality is beautifully serene. If you were to stand on one of these floating islands, the next closest asteroid would be hundreds of thousands of miles away, completely invisible to the naked eye. The space between them is so vast that robotic explorers sent from Earth pass through the belt with almost no risk of hitting anything at all. Each cosmic stone travels along its own solitary path, completely unaware of its neighbors drifting in the same dark ocean. This immense emptiness creates a profound sense of peace, where every single fragment enjoys its own private universe of silence. As we move among them, we see that the belt is not a crowded highway, but a sparse and tranquil desert of floating stone. One might imagine that a ring stretching across such an enormous distance would contain enough material to build a giant world, but the total mass is surprisingly small. If we were to gather every single asteroid, every speck of dust, and every frozen rock in this belt and melt them together, the resulting object would be smaller than our own moon. More than half of this entire mass is already contained within just 4 large objects, leaving the rest of the millions of stones as tiny crumbs. This revelation changes how we view the belt, transforming it from a broken planet into a delicate, sparse collection of cosmic remnants. It reminds us that in the grand scale of the cosmos, beauty often exists in the most fragile and scattered forms. We are looking at a landscape of minimalist design, where a little matter goes an incredibly long way across the void. These drifting fragments are scientifically classified as planetesimals, the original building blocks that were meant to construct the planets we know today. 4.5 billion years ago, a swirling disk of gas and dust surrounded our young sun, and particles began to stick together to form larger bodies. In other parts of the solar system, these pieces successfully combined to create worlds like Earth and Mars. But here, the process was permanently interrupted. Each asteroid is a time capsule from that ancient epoch, preserved in the freezing vacuum of space without any significant change. By studying these quiet stones, we are essentially looking at the raw, unaltered ingredients used to cook the entire solar system. They have waited in the dark for eons, holding onto clues about how our own home came to be. Long before telescopes were powerful enough to see these small rocks, mathematicians suspected that a hidden world must exist in the great gap between Mars and Jupiter. A mathematical sequence known as the Titius-Bode law suggested a specific pattern in the spacing of the planets, leaving a strange and empty void where a world should logically be. This mystery sparked a dedicated search among astronomers, who formed a group known as the Celestial Police to hunt down the missing member of our cosmic family. When they finally spotted the first faint glimmers of light in this region, they believed they had found the lost planet at last. Instead, they discovered that the universe had written a completely different story, one made of thousands of wandering pieces rather than a single sphere. This elegant surprise reminds us that nature rarely follows human expectations, choosing variety over conformity. The very word we use to describe these objects reflects the wonder they inspired when they were first observed through early telescopes. When the famous astronomer William Herschel looked at them, he noted that they did not appear as disks like other planets, but rather as tiny, star-like points of light. He coined the term asteroid, which literally translates to star like in ancient Greek, capturing their sparkling appearance against the dark velvet of the night sky. Unlike the planets that move with a visible presence, these stones disguised themselves as distant stars, hiding their true nature for generations. This poetic name serves as a constant reminder that even the smallest rocks in our system carry a touch of stellar beauty. They are the stars of the inner kingdom, small points of light charting their own quiet courses. As we look closer at the structure of this vast ring, we discover that it is not completely uniform, but is carved by invisible pathways of empty space. These clear lanes are known as the Kirkwood Gaps, named after the insightful astronomer who first noticed that certain regions of the belt were completely empty. These gaps are created by the gravitational resonance of giant Jupiter, which periodically pulls on any asteroid that enters these specific zones. Over millions of years, this repetitive gravitational tug acts like a cosmic broom, sweeping these paths clean and pushing the rocks into new orbits. This invisible architecture shows us that even in the open vacuum of space, gravity carves beautiful and intricate patterns out of chaos. The belt is therefore shaped not by physical walls, but by the silent, harmonic rhythms of planetary alignment. The diversity of the stones drifting in this belt is vast, and scientists categorize them based on what they are made of and how they reflect light. The most common varieties are the carbon-rich asteroids, which make up more than 75% of the entire population in the belt. These dark objects are deeply ancient and contain organic compounds, water ice, and minerals that have remained unchanged since the beginning. They appear almost pitch black against the dark of space, absorbing the faint sunlight and holding the secrets of the primitive solar nebula. Their dark surfaces remind us that the ingredients for life itself were forged in the deep cold of space, long before our world was born. They float like charcoal embers in the cosmic night, holding ancient memories of a time before the sun grew bright. Moving outward through the belt, we also encounter a different family of stones known as the silicate, or stony asteroids. These objects are much brighter than their carbon-rich cousins, and are composed primarily of iron and magnesium silicates mixed with pure metals. They represent the rocky crusts and mantles of early planetesimals that were heated and melted during the violent youth of our solar system. When sunlight hits their surfaces, they reflect a warm, greenish or reddish hue, standing out like jewels against the cold background of space. Each stony asteroid tells a story of intense heat, change, and the physical transformation of raw matter under cosmic pressure. They are the remnants of melted worlds, smoothed by time and preserved in the quiet cold. Every single one of these millions of fragments is bound by the law of gravity, tracing a slow and majestic path around our home star. A single journey around the sun takes these asteroids anywhere from 3 to 6 Earth years to complete, a slow migration through the deep dark. Their orbits are often slightly tilted and elongated, causing them to gently rise above and fall below the main plane of the solar system. This three-dimensional movement creates a complex, overlapping weave of paths that never truly tangle due to the immensity of space. As they quietly circle the sun over billions of years, they maintain a slow and steady rhythm, a timeless heartbeat that persists while empires rise and fall on the distant blue world we left behind. We watch them glide along their tracks, perfectly content in their endless, silent journey around the light. Beyond the dark carbon stones and the warm silicates, we encounter a rare and glistening family known as the metallic asteroids. These mysterious bodies are composed almost entirely of pure iron and nickel, shining with a subtle luster against the velvet dark. Scientists believe these metallic wanderers are the ancient fragments of the deepest interiors of early worlds that were torn apart by primordial collisions. As they float silently through the void, they reflect the distant sunlight with a distinct gleam, serving as floating archives of cosmic metal. They represent a chaotic chapter of our history, where worlds were broken before they could fully mature, leaving behind their strongest cores to drift forever. We watch them pass, smooth and heavy, riding the invisible currents of gravity. Among these metallic kingdoms, the most famous and captivating wanderer is the massive asteroid known as Psyche. This giant object is shaped like a rough stone and stretches over 140 miles across, making it one of the largest bodies in the entire belt. Unlike most other asteroids, which are made of rock or ice, Psyche appears to be a nearly exposed heart of a failed planet, stripped bare by ancient celestial impacts. When we imagine its surface, we do not see familiar dust, but rather a surreal landscape of metallic hills and iron cliffs. It floats as a priceless monument to the creation of our solar system, offering a rare glimpse into the deep interiors of worlds like our own Earth. Its presence reminds us that even the deepest secrets of nature can eventually be brought to light. To understand how a body like Psyche could exist, we must look back to a time when these primordial objects grew large enough to generate intense internal heat. During this ancient process, known to science as differentiation, the heavy metals like iron and nickel melted and sank slowly toward the center of the growing world. At the same time, the lighter, rocky materials floated to the top, forming an outer crust and a thick mantle layer around the core. This beautiful, layered structure is the exact same design found inside the Earth beneath our feet, showing that even small cosmic bodies followed the same laws of physics. It is a profound realization that these small stones were once on the path to becoming fully realized worlds, complete with their own hidden depths. They carry the blueprint of planetary anatomy, frozen in the middle of their evolution. The existence of pure metallic fragments tells us that the early solar system was a place of immense cosmic drama and colossal collisions. For a core like Psyche to be exposed to the freezing vacuum of space, a series of catastrophic impacts must have systematically stripped away its rocky outer crust and mantle. Imagine giant rocks smashing into each other at thousands of miles per hour, peeling away the outer layers of a young protoplanet over millions of years. What remained after the dust settled was the indestructible metallic center, cooled by the deep freeze of space. This process transformed a once living planetary seed into a silent monument of iron, a testament to the survival of the strongest materials in the cosmic furnace. It drifts now in perfect peace, a survivor of a long forgotten war of gravity. As we continue our drifting journey through this kingdom of stone, we come across the second most massive inhabitant of the belt, the magnificent asteroid Vesta. Vesta is a giant among fragments, so large that it is classified as a protoplanet, a world that successfully began the journey toward maturity. Unlike its completely spherical neighbor Ceres, Vesta has an irregular, slightly flattened shape that bears the deep scars of ancient impacts. Its surface is a fascinating mosaic of dark volcanic plains and bright highlands that tell a story of ancient geological activity. By studying Vesta, we are looking at a pristine survivor from the dawn of creation, a window into the era when the planets were first forming their crusts. It hangs in the dark like a fractured jewel, preserving the ancient history of fire and ice. When we gaze upon the southern pole of Vesta, we witness one of the most staggering features in the entire solar system, a colossal impact crater known as Resilvia. This immense depression is over 300 miles wide, meaning it covers almost the entire southern hemisphere of the protoplanet. At the very center of this impact site rises a massive mountain that climbs 13 miles into the sky, making it twice as high as Mount Everest on Earth. The impact that created this wound was so incredibly violent that it nearly shattered Vesta completely, sending a shockwave through its entire rocky body. This ancient event excavated deep into the mantle of the protoplanet, scattering millions of tons of rocky debris out into the open void. The vast basin remains a silent testament to the incredible forces that shaped our celestial neighborhood. The debris launched from that titanic collision at Vesta's south pole created a unique family of smaller fragments known to astronomers as the Vestoids. These thousands of smaller rocks share the exact same chemical signature as Vesta itself, drifting through the belt along similar orbital paths. Over millions of years, the gravitational currents of the solar system have nudged some of these fragments out of the belt, sending them toward the inner planets. Remarkably, many of these pieces have fallen to Earth as meteorites, allowing scientists to analyze actual pieces of Vesta's crust in their laboratories. This incredible connection reveals that the stories of these distant cosmic stones are physically written into the geology of our own home world. We are connected to the asteroid belt by a bridge of fallen stars that whispers secrets of the deep past. While some asteroids like Vesta are solid, differentiated worlds of rock and metal, many others belong to a completely different class known as rubble piles. These fascinating objects are not single, solid boulders, but rather loose collections of thousands of smaller stones, gravel, and dust held together by nothing more than weak gravity. They are formed when a previous asteroid is completely shattered by an impact, only for the scattered pieces to slowly drift back together over time. If you were to step onto a rubble pile asteroid, your boots would sink into a loose, shifting surface that behaves more like a fluid than solid ground. They float through the dark as fragile ghosts of destroyed worlds, held together by the gentlest gravitational embrace in the cosmos. Their existence shows us that destruction in space is often just the beginning of a new form of assembly. The internal structure of these rubble pile asteroids is filled with vast empty spaces and cavernous voids, making them incredibly light and porous. Because their gravity is so incredibly weak, the physics on their surfaces defies our earthly intuition in the most beautiful ways. A rock dropped from a height of a few feet would take minutes to gently drift down to the surface, landing without making a sound. The centrifugal force from the asteroid's slow spin can cause the loose stones at its equator to slowly migrate, reshaping the body over millions of years. This reveals that these cosmic rocks are not static monuments, but dynamic systems that slowly change shape as they dance through the void. They remind us that even the loosest assembly of matter can find a stable rhythm and survive for eons in the vacuum. Whether solid stone or loose rubble, almost every single asteroid in the belt is covered in a blanket of fine, powdery dust known as regolith. This cosmic soil is created over billions of years by the continuous bombardment of micrometeorites, tiny specks of dust traveling at unimaginable speeds. Each tiny impact pulverizes the surface rock, slowly grinding it down into a fine powder that clings to the asteroid in the weightless environment. This soft layer acts as a protective shield, absorbing the harsh radiation of the sun and insulating the cold interior of the rock from extreme temperature changes. As we watch the faint sunlight catch this powdery surface, we see a landscape softened by time, where the violent history of the cosmos has been ground down into a gentle, silent dust. It coats each wanderer like a soft velvet blanket, bringing a quiet uniformity to the scattered empire of stone. When we contemplate the sparse nature of this ring today, it is astonishing to realize that it was not always so empty. In the very beginning, during the dawn of the solar system, this region held a tremendous amount of material, perhaps equal to several times the mass of the Earth. There was more than enough matter floating here to forge a magnificent rocky planet, one that would have sat proudly between Mars and Jupiter. Yet, through a slow and dramatic process of cosmic eviction, nearly all of this original material was scattered across the solar system or swallowed by the sun. The emptiness we observe now is the quiet aftermath of a massive cosmic clearing, leaving behind less than 1% of the original mass. This vast missing history reminds us that space is an ever-shifting landscape, where what remains is only a tiny whisper of what used to be. The great architect of this grand clearing was none other than Jupiter, whose early movements shook the foundations of the inner solar system. According to modern scientific theories, the giant gas planet did not stay in its original birthplace, but drifted inward toward the sun like a massive cosmic ship. This journey, often called the Grand Tack, allowed Jupiter's immense gravity to plow through the young asteroid belt, acting like a giant gravitational rake that scattered everything in its path. Later, the gravitational pull of Saturn tugged Jupiter back out to its current position, but the damage to the asteroid belt was already done. This celestial dance left the region permanently depleted, completely reshaping the architecture of our cosmic neighborhood before the planets could even finish growing. It shows how the migrations of giants can dictate the fates of smaller worlds across the void. In a normal planetary environment, when two small rocks drift toward one another, their gentle speeds allow them to stick together and grow into something larger. However, the constant stirring from Jupiter completely changed the rules of engagement within this ancient ring. The giant planet accelerated the speeds of the asteroids, causing them to move much too fast for a peaceful union. Instead of merging gently to form a new planet, these cosmic stones began to smash into one another with destructive velocity, shattering upon impact. This shifted the entire region from an environment of planetary growth to one of continuous fragmentation and erosion. The rocks were locked in a perpetual state of breaking down rather than building up, ensuring that a unified world could never rise from the rubble. Running silently through the middle of this rocky kingdom is one of the most important boundaries in astrophysics, known as the frost line. This invisible frontier marks the precise distance from the young sun, where temperatures dropped low enough for volatile compounds like water, ammonia, and methane to freeze into solid ice. Inside this line, the sun's warmth kept these materials as gas, leaving only dry rock and metal to form the inner asteroids. Outside this boundary, ice became a common building material, mixing with the stone to create a completely different type of cosmic body. The asteroid belt stands as a unique archive because it straddles this exact line, preserving both the dry stones of the inner world and the icy remnants of the outer domain. It is a cosmic crossroads where fire and ice found a permanent, quiet balance. As these rocks drifted through the eons, their violent history created distinct clans known to astronomers as asteroid families. These groups consist of thousands of individual stones that travel along almost identical paths around the sun, bound by a shared genetic history. Each family is the scattered remains of a single, large parent body that was completely blown apart by a catastrophic collision long ago. By tracing the paths of these fragments backward through time, scientists can reconstruct the exact moment of the impact, like putting together the pieces of an ancient puzzle. Families like the Flora or Coronus clans tell us that the belt is not a random collection of rocks, but a structured network of ancestry. They float together through the darkness, carrying the shared chemical signature of a world that was lost to the void. Even the gentle light of our distant star holds the power to slowly alter the destinies of these wandering stones over vast spans of time. This subtle phenomenon, known as the Yarkovsky effect, occurs as an asteroid absorbs sunlight on its daytime side and radiates that heat back into space as it rotates into the dark. This release of thermal energy acts like a microscopic rocket thruster, providing a tiny but relentless push to the rock. Over millions of years, this minuscule force can nudge an asteroid across millions of miles, completely changing its orbit and moving it into new regions of space. It is a beautiful demonstration of how the softest touch of light can conquer the heaviest stones if given enough time. The universe reminds us that change does not always require violent collisions, but can happen through the quiet persistence of a sunbeam. Sunlight also influences these cosmic stones in another profound way, affecting how they spin as they drift through the emptiness. When photons from the sun strike the uneven, asymmetrical surfaces of an asteroid, they exert a tiny amount of rotational torque. This process, called the YORP effect, can slowly speed up or slow down the rotation of the rock over thousands of generations. If an asteroid is spun up too fast, the centrifugal force can eventually exceed the weak gravity holding the object together. When this threshold is crossed, the asteroid can literally tear itself apart, shedding rocks and dust into space or splitting into completely separate bodies. We see that the sun acts not just as a source of light, but as a silent sculptor, gently spinning these worlds until they reshape themselves. As we watch these stones glide through the dark, we discover that many of them do not travel alone, but have found companions in the silence. Astronomers have discovered numerous binary and even triple asteroid systems, where a larger central rock is orbited by one or more tiny companion moons. The first of these to be seen was the asteroid Ida, which surprised scientists when a spacecraft revealed a tiny, mile-wide moon named Dactyl orbiting gracefully around it. These miniature systems are often formed during ancient collisions, when the debris thrown from an impact is caught by the remaining rock's gravity. They look like miniature solar systems operating on a tiny scale, proving that the laws of orbital motion apply equally to giants and fragments alike. They dance together through the void, keeping each other company in the vast loneliness of space. Occasionally, the boundary between asteroids and comets becomes beautifully blurred, revealing a rare class of objects known as active asteroids. For billions of years, these bodies look like ordinary, dry rocks, completely indistinguishable from their stony neighbors. However, if a random impact chips away their protective coating of dust, it can expose hidden pockets of ancient ice buried deep within their interiors. When this pristine ice is suddenly exposed to the faint warmth of the sun, it instantly vaporizes into gas, creating a bright, glowing tail of dust behind the rock. This sudden transformation makes an ordinary asteroid look exactly like a comet, showing that many of these stones are hiding frozen secrets from the dawn of time. They are the sleeping ice worlds of the inner system, waiting for the right moment to show their true nature. The complex gravitational network of the belt also contains invisible exit pathways that connect these distant rocks directly to the inner planets. When the Yarkovsky effect, or a random collision, nudges an asteroid into one of the Kirkwood gaps, it enters a zone of intense gravitational instability. The rhythmic, repetitive pull of Jupiter acts like a cosmic slingshot, rapidly destabilizing the asteroid's orbit and pushing it out of the main belt entirely. Many of these displaced rocks are sent on paths that plunge into the inner solar system, becoming the near-Earth asteroids that occasionally cross our own planetary path. This continuous leakage ensures that the asteroid belt is not a closed container, but a living, breathing system that shares its ancient treasures with the rest of the cosmos. It reminds us that the quiet ring of stone we are exploring is intimately woven into the greater story of our own home. As we float deeper into this ocean of quiet stone, we begin to notice how differently these wanderers interact with the faint light of the distant sun. Some surfaces are incredibly dark, absorbing almost every photon that strikes them, while others gleam with a surprising brightness. Scientists measure this reflective quality using a concept called albedo, which tells us how much light a celestial body bounces back into the void. Because many of these rocks are so dark, they remain virtually invisible to ordinary optical telescopes against the black canvas of space. Instead, astronomers must use space-based infrared telescopes to look for the gentle warmth these rocks emit after being heated by the sun. This hidden glow reveals thousands of stealthy travelers that would otherwise remain completely lost in the shadows of the solar system. At the very inner boundary of this grand cosmic ring, closest to the orbit of Mars, resides a specific group of bright stones known as the Hungaria family. These asteroids are locked into a unique pocket of stability, protected by a specific gravitational resonance that keeps them separate from the rest of the main belt. Because they sit so close to the warmth of the inner solar system, they are mostly composed of bright, rocky materials that reflect a significant amount of sunlight. Their orbits are highly tilted, lifting them well above the crowded plain where most other fragments drift. Looking down from their elevated paths, these bright sentinels guard the inner gateway to the belt, maintaining their unique rhythm for billions of years. They represent a distinct outpost of stone, refusing to mix with the darker populations that lie further out in the deep freeze. On the completely opposite side of the belt, near the freezing outer edge where Jupiter's domain begins, we find an extraordinary collection of rocks called the Hilda family. These distant wanderers do not travel in simple circles, but instead form a magnificent, shifting triangle configuration in space as they orbit the sun. This incredible geometric arrangement is maintained by a precise 3:2 orbital resonance with giant Jupiter itself, meaning they complete 3 orbits for every 2 orbits of the gas giant. As Jupiter moves, the Hildas constantly shift their positions to avoid ever coming too close to the monster planet's destructive gravitational core. This beautiful, synchronized choreography looks like a living geometric pattern drawn across the outer solar system. It shows us that even on the edge of chaos, the universe finds a way to establish a steady, mathematical harmony. The surfaces of these ancient stones are constantly undergoing a subtle and invisible transformation known to science as space weathering. Without a protective atmosphere to shield them, the rocks are completely exposed to the harsh, relentless environment of open space. For eons, the solar wind streams across the void, bombarding the asteroid surfaces with high-energy protons and alpha particles. At the same time, tiny microscopic dust particles strike the rocks at extreme speeds, vaporizing tiny amounts of material and leaving microscopic coats of iron behind. This continuous celestial rain slowly darkens and reddens the surfaces of the asteroids over millions of years, altering their original appearance. It is a slow, cosmic aging process where the touch of the sun leaves an indelible mark on the skin of every wandering world. Deep within this silent wilderness, these floating worlds experience extreme temperature swings that slowly break down their physical structures from within. As an asteroid rotates in the dark, its surface transitions rapidly from the freezing cold of deep space to the sudden warmth of direct sunlight. This constant, repetitive cycle of heating and cooling causes the minerals within the rock to expand and contract at different rates. Over immense spans of time, this physical stress creates tiny microfractures that slowly spiderweb through the solid stone, a process called thermal fatigue. Eventually, even the hardest boulders are weakened by this silent tension, fracturing into smaller stones and contributing to the fine dust layer that blankets them. It is a gentle, patient form of erosion that requires no wind or water, only the alternating touch of light and shadow. To unravel the deep secrets of what these distant rocks are made of, scientists analyze the faint sunlight that bounces off their surfaces. By splitting this reflected light into a beautiful rainbow spectrum, astronomers can look for specific missing colors known as absorption lines. Each mineral, whether it is pyroxene, olivine, or ancient carbon, leaves its own unique fingerprint written into the structure of the light. This incredible scientific technique allows us to determine the precise chemical makeup of an object that is hundreds of millions of miles away without ever touching it. The reflected light becomes a silent messenger, carrying the molecular blueprint of the asteroid across the vast emptiness to our waiting instruments. It reminds us that every beam of light in the cosmos is filled with information, waiting to tell the story of its origin. Many of the oldest and most primitive stones in this grand ring belong to a group of meteorites known as chondrites, which contain tiny, spherical grains called chondrules. These microscopic droplets were formed when dust clouds in the early solar nebula were suddenly melted by mysterious flashes of energy before the planets even existed. As the nebula cooled, these droplets solidified and were gently packed together with dust and metal to form the very first rocky bodies of our system. Because these asteroids never grew large enough to melt and differentiate, they have preserved these pristine droplets in their original, unaltered state for over 4 billion years. When we look at these chondritic stones, we are looking at the foundational sediment of our entire cosmic neighborhood. They are the ancient seeds of the solar system, holding the primitive chemistry from which all rocky worlds were grown. Because the gravity of these scattered fragments is so incredibly weak, none of them possess the strength to hold onto a protective blanket of atmosphere. Any gas that might be released from their interiors through warming or impacts instantly escapes into the greedy vacuum of space, leaving the surfaces perfectly bare. This complete lack of air means there is no weather, no sound, and no sky coloration on these lonely worlds. The sky is always a deep, pitch-black void filled with unblinking stars. The sun shines with a harsh, unfiltered glare, casting sharp, ink-black shadows that show no soft transition between light and dark. This stark environment creates a landscape of absolute clarity, where every rock and dust grain is preserved in a pristine vacuum. It is a realm of pure geometry and quiet isolation, where the absence of air amplifies the profound silence of the cosmos. The history of this rocky belt is intimately tied to a chaotic epoch known as the Late Heavy Bombardment, which occurred hundreds of millions of years after the planets formed. During this ancient time, the giant outer planets shifted their orbits, sending a massive wave of gravitational disruption rippling through the asteroid belt. This cosmic disturbance destabilized the paths of millions of stones, sending them hurtling into the inner solar system like a storm of missiles. These wandering fragments slammed into the young planets and moons, carving out the massive impact basins we still see on our moon today. The asteroid belt acted as a giant cosmic reservoir, supplying the raw materials that battered the early surfaces of Earth and Mars. This violent era permanently shaped the faces of the inner worlds, showing that the quiet belt was once a source of immense geological change. Perhaps the most profound connection between this distant ring of stone and our own existence lies in the ancient delivery of water to the early Earth. While our young planet formed close to the sun, where it was much too hot for water to easily freeze and remain, the outer regions of the asteroid belt were rich in icy minerals. Over billions of years, countless carbon-rich asteroids from these colder zones were nudged out of their orbits and plunged into the inner solar system, colliding with the young Earth. These incoming rocks carried precious water molecules locked tightly within their crystalline structures, slowly releasing them upon impact to form our first oceans. Recent scientific studies show that the chemical signature of the water in our oceans perfectly matches the water found within these ancient carbonaceous asteroids. This reveals that the very water that flows through our rivers and sustains our lives was brought to us by the silent wanderers of the Asteroid Belt. As we float further along this grand river of time and stone, we encounter the remarkable world of Pallas, the second asteroid ever to be discovered, and the third largest body in the entire region. Pallas is a massive, irregular sphere that holds a significant percentage of the remaining mass within the entire belt. What makes this ancient wanderer truly extraordinary is its highly tilted orbit, which plunges up and down through the main planetary plane at a steep angle. This sharp inclination causes Pallas to spend most of its time traveling far above or below its celestial neighbors, viewing the rest of the belt from a lonely distance. Scientists believe this erratic path was caused by a colossal gravitational encounter during the chaotic youth of our solar system. It moves like a solitary phantom, tracing an eccentric trail that keeps it isolated from the common paths of the smaller rocks. Not far from the path of Pallas drifts another historical giant of the Inner Kingdom, the fascinating asteroid known as Juno. Discovered shortly after its larger companions, Juno was initially thought to be a full planet before its true, smaller nature was revealed by advancing telescopes. It is a prominent member of the stony asteroid family, exceptionally rich in silicate minerals mixed with heavy deposits of iron. Juno possesses an elongated, asymmetrical shape, resembling a giant cosmic potato tumbling slowly through the eternal dark. Its surface features a dramatic variation in brightness, suggesting a complex landscape of dark impact craters and highly reflective plains of fresh stone. As it completes its journey around the Sun every 4 Earth years, Juno reminds us of the endless variety of shapes that matter can assume when free from the pulling force of heavy planetary gravity. When we observe the motions of these millions of floating fragments, we discover an invisible law governing how fast they are allowed to spin through the void. Astronomers have noticed a strict cosmic speed limit known as the spin barrier, which prevents any asteroid larger than a few hundred yards across from rotating faster than once every 2 hours. If an asteroid were to spin any faster than this critical threshold, the outward centripetal force would completely overcome its weak internal gravity. Because many of these bodies are loose rubble piles rather than solid rock, spinning too fast would cause them to instantly fly apart into a cloud of scattered pebbles. This elegant physical boundary acts as a silent regulator, ensuring that the larger islands of stone maintain their integrity as they drift. It shows that even in the lawless wild of deep space, the laws of rotational mechanics enforce a beautiful, balancing order. This delicate balance is intimately tied to the surprising internal structure of the smaller stones, which are often far less solid than they appear from the outside. Many of these wandering objects possess an incredibly high level of porosity, meaning that up to half of their total volume consists of completely empty space and hidden caverns. Instead of being solid pieces of bedrock, they behave like massive, floating sponges made of cosmic dust and fragmented gravel. This hollow design cushions them against the shock of minor impacts, allowing them to absorb energy without shattering completely into pieces. When a small meteorite strikes a porous asteroid, it often leaves a neat compaction crater rather than fracturing the entire body. This unique structural resilience has allowed thousands of fragile rubble piles to survive billions of years of cosmic bombardment intact. To determine how long these silent sentinels have been drifting in the dark, scientists look closely at the atomic clocks ticking inside the meteorites that fall to Earth. By measuring the slow, predictable decay of radioactive isotopes like uranium and lead trapped within these stones, researchers can calculate their exact age with astonishing precision. The results of these cosmic tests consistently reveal that the asteroids are 4,568,000,000 years old. This immense age means they are older than the Earth itself, having solidified before our own planet had even finished gathering its initial layers. They are the oldest physical objects we can touch, holding the literal timestamps of the very beginning of our solar system. Looking at them is like looking at the frozen foundation stones of time itself, untouched by the geological activity that erased the history of larger worlds. As these millions of stones slowly tumble along their orbits, they leave behind a faint, glowing trail of dust that reveals the hidden structure of the belt. Space-based infrared telescopes have discovered distinct, parallel bands of warm dust that circle the entire solar system within the main ring of the belt. These elegant bands are the lingering debris from relatively recent collisions between large asteroid families that occurred millions of years ago. The tiny dust particles gradually spread out along the orbits of the parent rocks, creating a delicate cosmic highway of microscopic shards. This dust slowly spirals inward toward the sun over millions of years, illuminated by the faint sunlight like motes of dust dancing in a dark room. It shows us that the belt is a living, changing system, continuously producing new layers of beauty from its ongoing history of gentle destruction. Among the darker populations of the belt, we occasionally find rare and brilliant anomalies known to astronomers as E-type asteroids. These unusual rocks are characterized by surfaces made of a bright, translucent mineral called enstatite, which gives them a remarkably high reflectivity. The most famous example of this family is the asteroid Nyssa, which gleams like a pale jewel against the dark velvet canvas of open space. Scientists believe these bright stones are the remnants of the outer crusts of ancient, melted worlds that were exceptionally rich in sulfur and poor in iron. When sunlight hits their surfaces, they glow with a unique, glassy brilliance that separates them from the charcoal-colored rocks nearby. They drift through the dark like fragments of fine porcelain, preserving a rare and highly specific chapter of cosmic chemistry. When we step back and look at the asteroid belt as a whole, we perceive a beautiful, orderly gradient in its chemical composition that reflects the conditions of the early solar nebula. The inner regions, closer to the Sun, are dominated by bright, rocky stones that could withstand the intense heat of the young star. As we move outward toward the frozen kingdom of Jupiter, the population smoothly transitions into darker, carbon-rich rocks, and eventually into bodies heavy with ancient water ice. This structured distribution shows that the belt is a frozen map of the temperature variations that existed 4 billion years ago. The rocks have stayed in their respective zones for eons, maintaining the original order of the cloud from which they were born. It is a grand cosmic library where each shelf represents a different distance from the heart of our star. For generations, these distant stones were nothing more than faint points of light in our night sky. But humanity has recently reached out to touch them in the silence. The historic spacecraft Galileo was the very first robotic explorer to fly close to an asteroid, capturing the first detailed images of the rocky surfaces of Gaspra and Ida. Later, the pioneering NEAR Shoemaker mission achieved the incredible feat of orbiting and eventually landing gently on the surface of the asteroid Eros. These courageous robotic emissaries revealed a world of stunning complexity, covered in vast crater fields, giant boulders, and smooth plains of fine dust. They transformed our understanding of these objects from simple rocks into complex, individual worlds with their own unique geological stories. These achievements marked the beginning of a new era of exploration, where the silent deserts of stone became real places we could study and understand. Now, our long, drifting journey brings us to the threshold of the undisputed monarch of this entire rocky realm, the majestic dwarf planet Ceres. Nestled deep within the middle of the main belt, Ceres looms large in the darkness, accounting for a massive 1/3 of the entire mass of the region. Unlike its irregular neighbors, Ceres possesses enough gravitational strength to pull itself into a perfect, serene sphere of ice and stone. It hangs in the deep dark like a miniature planet, a quiet bridge between the rocky inner worlds and the icy outer giants. As we prepare to explore its mysterious features, we feel the profound shift in scale, leaving the scattered fragments behind to enter the gravity of a true celestial queen. It waits for us in the silence, a hidden world of frozen oceans and glowing craters, ready to reveal its ancient secrets. When the first day of the 19th century dawned, astronomer Giuseppe Piazzi noticed a faint, moving point of light in the constellation of Taurus. He had been carefully mapping the stars when he stumbled upon this shifting presence, a silent wanderer that perfectly matched the mathematical predictions for a missing world. For a brief, glorious period, humanity celebrated the discovery of a brand new planet residing peacefully in the vast gap between Mars and Jupiter. It was named Ceres, after the Roman goddess of agriculture and harvests, reflecting a deep hope that this new world would be a fertile addition to our celestial family. Although it was later reclassified as the largest of the asteroids, that initial sense of wonder remains perfectly intact as we gaze upon its spherical form today. It stands as a profound reminder of how our understanding of the cosmos constantly evolves, shifting our perspective with every new point of light we find in the dark. As we draw nearer to Ceres, its sheer scale sets it entirely apart from the jagged, irregular rocks that scatter the rest of the belt. Spanning nearly 600 miles across, this magnificent body is massive enough that its own internal gravity has conquered the strength of solid rock. Over billions of years, this invisible pulling force smoothed out the rough edges, slowly molding the world into a perfectly balanced, serene sphere. This makes Ceres the only officially recognized dwarf planet residing in the inner solar system, a quiet sovereign ruling over a fragmented kingdom. Its rounded shape gives it a sense of ancient calmness, a finished masterpiece resting calmly in a region defined by broken pieces and chaotic collisions. It drifts through the dark space with a majestic grace, a solitary pearl floating in a sprawling ocean of rough stone. Beneath the dusty, dark gray surface of this dwarf planet hides a secret that completely transforms our view of the inner solar system. Scientists have discovered that Ceres is incredibly rich in water, with massive layers of ice making up nearly a quarter of its entire mass. If all the ice hidden beneath its crust were suddenly melted into liquid, it would hold more fresh water than all the lakes and rivers present on Earth. This staggering abundance of ice changes Ceres from a dry, barren rock into a frozen water world, waiting silently in the cold vacuum of space. It is a massive cosmic reservoir, preserving the pristine, ancient waters from the dawn of the solar nebula locked safely beneath its dusty skin. The presence of so much ice proves that the dividing line between dry rocks and wet comets is not a sharp border, but a beautiful, blurred transition. As we glide over the northern hemisphere, a startling feature captures our attention, glowing against the dark landscape like a cosmic beacon. Deep within a massive impact basin known as Asteroid Crater, a series of brilliant, luminous spots reflect the distant sunlight with an almost unnatural intensity. When these bright patches were first photographed by approaching spacecraft, they sparked intense wonder, shining like forgotten cities deep in the silent void. We now know that these luminous features, called faculae, are massive deposits of highly reflective salts, specifically sodium carbonate, left behind by evaporating water. They are the chemical scars of an active world, where briny fluids from the deep interior seeped through fractures in the crust and crystallized in the freezing vacuum. These glowing plains of salt stand as a breathtaking testament to the complex geology of a world we once thought was completely dead and still. Rising alone above the heavily cratered plains is a solitary, towering mountain named Ahuna Mons, a geological marvel that defies all expectations. This massive peak stands over 2.5 miles high, its smooth, steep flanks contrasting sharply with the ancient, battered terrain that surrounds it. Ahuna Mons is not a mountain built by colliding tectonic plates, nor is it a volcano that erupts hot, molten magma like those on Earth. Instead, it is a magnificent ice volcano, a cryovolcanic dome created when freezing, muddy brine pushed its way up from the deep interior and froze upon reaching the surface. Over time, these slow, freezing eruptions built a massive mountain of ice and salt, standing completely alone under the black sky. It is a silent, frozen monument to the strange and beautiful volcanic forces that operate in the extreme cold of the outer solar system. Though it lacks the thick, protective blanket of air we find on Earth, Ceres possesses a delicate and temporary atmosphere that breathes with the rhythm of its orbit. As the dwarf planet travels closer to the Sun, the gentle increase in warmth causes hidden pockets of water, ice near the surface, to slowly turn into vapor. This process, known as sublimation, releases a faint mist of water molecules that completely surrounds the icy sphere, creating a fragile, whispering exosphere. When Ceres drifts back into the colder regions of its orbit, this gentle atmosphere settles back down to the surface, freezing once more into solid frost. This incredible cycle means that Ceres gently breathes as it dances around the Sun, exhaling a faint cloud of vapor during its long cosmic summer. It is a beautifully subtle interaction between light and ice, adding a delicate layer of movement to a quiet world. The profound secrets of Ceres lie not just on its cratered surface, but deep within its layered, hidden architecture. By studying the subtle variations in its gravity, scientists have deduced that Ceres has a heavily differentiated interior, much like the larger planets we know. It possesses a solid core of dense rock at its very center, wrapped inside a thick, protective mantle composed almost entirely of water ice and ancient clays. Some planetary geologists believe that deep beneath the icy crust, a layer of muddy, liquid water may still exist, kept warm by the lingering heat of ancient radioactive decay. This hidden, muddy ocean could be slowly circulating in the dark, a silent sea trapped beneath miles of frozen rock for billions of years. The possibility of liquid water hidden in the asteroid belt expands our understanding of where the conditions for complex chemistry might exist in the dark. Our exploration of this icy dwarf planet yielded yet another profound surprise when instruments detected the complex chemical signatures of life's building blocks. Near a large crater named Ernutet, scientists discovered concentrated patches of aliphatic organic compounds spread across the dark surface of the world. These carbon-based molecules are the essential ingredients necessary for the formation of life. Resting quietly on the surface of an alien sphere, hundreds of millions of miles from home. The exact origin of these organic materials remains a beautiful mystery, as they may have been delivered by impacting comets, or they might have formed deep within the warm, muddy interior of Ceres itself. Finding these complex molecules on a frozen world in the asteroid belt suggests that the raw ingredients for life are scattered generously throughout the cosmos. It turns this silent, icy globe into a chemical laboratory, holding the ancient recipes of creation in the deep freeze of space. As we analyze the minerals embedded in the dusty crust of Ceres, we find elements that seem completely out of place in this region of the solar system. The surface is rich in ammoniated clays, minerals that contain ammonia, a compound that normally only freezes in the extreme cold found far beyond the orbit of Jupiter. The presence of this frozen ammonia suggests a captivating theory that Ceres may not have been born in the main asteroid belt at all. Instead, it might have formed in the distant, freezing outer edges of the solar system, only to be slowly pushed inward by the gravitational migrations of the giant planets. If this is true, Ceres is a magnificent cosmic immigrant, a wanderer from the deep cold that found a stable home in the warmer inner ring. It carries the chemical fingerprints of the outer dark, a silent visitor from the distant edge of the sun's domain. All of these incredible details were brought to light by the quiet and patient journey of a robotic emissary named Dawn. This remarkable spacecraft traveled for years through the open vacuum, powered by a gentle, glowing blue beam of ion propulsion. Dawn became the very first human-made object to enter orbit around a dwarf planet, matching the exact speed and path of Ceres to become its temporary mechanical moon. For years, it silently circled the icy world, mapping every crater, every glowing patch of salt, and every towering ice mountain with flawless precision. When its mission finally ended and its fuel ran dry, Dawn was left in a perpetual, silent orbit, a permanent monument to human curiosity circling an ancient world. Together, the icy dwarf planet and its silent metallic moon drift through the belt, a beautiful testament to our desire to understand the dark. As we drift away from the frozen majesty of Ceres and the silent vigil of the Dawn spacecraft, we return to the scattered, irregular shapes of the smaller wanderers. While Ceres possessed the immense gravity to pull itself into a perfect sphere, most of the belt is populated by objects that lack such power, resulting in a fascinating gallery of bizarre and beautiful shapes. Among these oddities, we find strange formations known as contact binaries, where two completely separate rocks gently drifted together and fused. Instead of shattering each other in a high-speed impact, they touched softly in the dark and remained locked in a permanent embrace. Over millions of years, cosmic dust and weak gravity smoothed their connection, creating forms that resemble giant peanuts or irregular dumbbells floating through the void. They are a testament to the fact that gravity, no matter how gentle, always seeks to pull the broken pieces of the universe back together in the quiet dark. One of the most famous and peculiar of these oddly shaped bodies is the metallic asteroid named Cleopatra. When radar signals from Earth finally resolved the true shape of this distant wanderer, scientists were astonished to find a massive, metallic object resembling a giant dog bone. Cleopatra consists of two large, rounded lobes of iron and nickel, connected by a thick, elongated neck of rubble and stone. Astronomers believe it was formed from the remains of a violent collision, where heavy metallic debris slowly gathered itself back into this highly unusual, elongated structure. It tumbles end over end through the cold vacuum, a shining, bizarre monument to the unpredictable architecture of space. It reminds us that without the dominant force of heavy planetary gravity, matter is free to assume the most whimsical and unexpected forms imaginable. The strange story of Cleopatra becomes even more remarkable when we observe its surrounding space. For this tumbling bone of metal does not travel alone. Orbiting closely around its elongated body are two tiny moons, beautifully named Elyx Helios and Cleoslene, dancing quietly in the dark. Because Cleopatra spins so rapidly on its axis, the centrifugal force at its equator is incredibly strong, almost enough to overcome its own gentle gravitational pull. Scientists believe these two small moons were actually born from the asteroid itself, formed when loose dust and rubble were literally flung off the equator into open space. These pieces gathered together in orbit, becoming loyal companions to the parent rock that cast them away. It is a miniature, self-contained system of creation, where a spinning stone gives birth to its own tiny satellites in the silent depths. This phenomenon of rapid rotation reshaping a rocky body is also responsible for a specific class of asteroids shaped like giant, floating diamonds or spinning tops. As the gentle, unequal warming of the sun gradually speeds up the rotation of a loose rubble pile asteroid, the rocks and dust begin to slowly migrate. Over hundreds of thousands of years, the loose material slides down from the poles and gathers around the middle, creating a pronounced, bulging equator. This slow avalanche of cosmic dust perfectly sculpts the asteroid into an elegant, diamond-like symmetry, a shape born entirely from the delicate interplay of light and gravity. Wanderers that originated in the main belt carry this beautiful, geometric shape as a physical record of their interaction with the sun. They spin like silent, ancient tops, carved not by hands, but by the persistent touch of starlight. Hidden within these battered, irregular fragments is a wealth of rare elements that are incredibly difficult to find on the surface of our own world. When the Earth was young and molten, heavy, precious metals like platinum, iridium, and gold sank deep into the planetary core, far beyond our reach. However, in the asteroid belt, the catastrophic collisions that shattered ancient protoplanets left these dense, precious materials completely exposed to the vacuum of space. A single, medium-sized metallic asteroid drifting unnoticed in the dark can contain more precious metals than have ever been mined in the entire history of human civilization. These floating treasures remain untouched, silently orbiting the sun in a state of raw, primordial abundance. They are the scattered, golden hearts of failed worlds, drifting like loose coins in the grand, dark ocean of the solar system. The endless, slow-motion grinding of all these millions of stones creates a gentle byproduct that stretches all the way back to our home planet. Every time two small asteroids collide, or a micrometeorite strikes a larger boulder, a tiny cloud of fine, powdery dust is released into the void. Over billions of years, this continuous cosmic erosion has filled the inner solar system with a vast, incredibly faint disk of microscopic particles. When sunlight catches this sprawling sea of dust, it creates a subtle, ethereal glow known as the zodiacal light, which can sometimes be seen from Earth just before sunrise or after sunset. This pale, ghostly wedge of light stretching up from the horizon is the physical reflection of the asteroid belt itself, painting our twilight skies. It is a beautiful realization that the dust of shattered worlds is visible to the naked eye, glowing softly in the quiet moments of the dawn. The complex, overlapping pathways of these fragmented worlds were first deeply understood over a century ago by a patient and dedicated astronomer named Kiitsugu Hirayama. While studying the orbital tracks of thousands of asteroids, he noticed that many of them shared remarkably similar paths, moving together in vast, loose clouds. He realized that these groups were not random, but were the scattered children of much larger parent bodies that had been destroyed eons ago. By mathematically tracing their paths backward through time, he proved that these rocks were blood relatives, sharing the exact same chemical structure and orbital history. Today, these deeply connected groups are known as the Hirayama families, a beautiful tribute to the man who found order in the chaos of the belt. They remind us that even the most shattered and scattered pieces of the cosmos remain, forever bound by their shared origins. Not every rock that originates in this great ring stays confined within its safe, established borders. Through the slow nudging of thermal forces and the invisible gravitational traps of Jupiter, some fragments are cast out of the main belt and into highly elliptical, wandering orbits. These rogue stones embark on long, eccentric journeys that bring them plunging into the warm inner solar system, crossing the paths of Mars and Earth. They are the nomads of the rocky kingdom, trading the quiet isolation of the main belt for a dynamic, dangerous dance with the inner planets. Their extreme orbits carry them from the freezing outer dark all the way to the blinding heat of the inner sun, living a life of profound temperature extremes. They serve as physical messengers, carrying the ancient material of the belt directly to the doorsteps of the terrestrial worlds. Even though these wandering stones lack the atmosphere and oceans that drive the seasons on Earth, many of them experience a strange and extreme form of cosmic weather. Because their axes of rotation are often wildly tilted due to ancient collisions, their northern and southern poles can be pointed directly at the sun for years at a time. This creates an environment of absolute contrast, where one side of the rock bakes continuously in the harsh, unfiltered solar glare, while the other side freezes in absolute, eternal night. These long, extreme seasons cause the rock to expand and contract unevenly, creating deep thermal stresses that slowly fracture the stone over millennia. It is a harsh, silent climate defined purely by light and shadow, where the changing of the seasons is marked only by the slow, creeping line of the Terminator. In this airless void, a summer can last for years, measured only by the steady warming of the ancient dust. If we were to drift alongside these ancient stones and witness one of their rare, violent collisions, the experience would be profoundly different from anything we know on Earth. When two massive boulders smash into each other at thousands of miles per hour, the impact releases enough energy to shatter rock and melt iron in an instant. Yet, in the perfect vacuum of space, this apocalyptic destruction occurs in absolute, chilling silence. There is no air to carry the shockwave, no atmosphere to transmit the sound of breaking stone, leaving only the sudden, blinding flash of vaporized rock and the silent scattering of debris. It is a surreal and hypnotic ballet of destruction, where whole mountains are torn apart without a single whisper reaching our ears. This profound quiet amplifies the majesty of the cosmos, reminding us that the grandest events in the universe unfold in a deep, unbreakable silence. Even in the profound silence of their drifting, we can trace the exact outlines of these unseen wanderers through a celestial phenomenon known as a stellar occultation. As an asteroid glides along its orbit, it occasionally passes directly in front of a distant star, briefly blocking its light from reaching our earthly telescopes. For a few fleeting moments, the distant star seems to wink out of existence, casting a fast-moving, invisible shadow that races across the surface of our planet. By placing multiple observers along the path of the shadow, astronomers can precisely time exactly how long the star disappears from view at different locations. When these timings are combined, they draw a perfect, high-resolution silhouette of the asteroid, revealing its shape and size with astonishing accuracy without ever leaving the ground. It is a beautiful cosmic shadow play, where the oldest rocks in our system temporarily eclipse the ancient light of distant suns, allowing us to see them by the very light they steal. To further pierce the darkness and reveal the true topographies of these floating stones, humanity has learned to reach out and touch them with invisible waves of energy. Using massive radar dishes stationed on Earth, astronomers project powerful beams of radio waves deep into the void, aiming precisely at the predicted path of an approaching asteroid. These invisible waves travel for millions of miles through the empty dark until they strike the rugged, dusty surface of the stone and scatter in all directions. A tiny fraction of these radio waves bounces back toward Earth, returning as an incredibly faint echo that carries detailed information about the rock's rotation, texture, and shape. By carefully analyzing these returning echoes, scientists can construct incredibly detailed, three-dimensional models of worlds that appear as nothing more than a single pixel to optical telescopes. It is a form of celestial echolocation, allowing us to map the silent mountains and craters of the void by listening to the subtle reflections of our own radio calls. Deep inside the fallen fragments of the belt that managed to survive the fiery descent through our atmosphere, scientists have discovered materials that defy the age of our solar system. Hidden within the carbon-rich meteorites are microscopic specks of diamond, graphite, and silicon carbide that are known to astrophysicists as prosolar grains. These incredibly resilient particles were forged in the dying atmospheres of ancient red giant stars, and the catastrophic explosions of supernovae that occurred long before our sun was even born. They drifted through the cold interstellar medium for untold eons before becoming trapped in the swirling dust cloud that would eventually collapse to form our solar neighborhood. Because the asteroids in the main belt never grew large enough to melt and destroy these tiny relics, they have acted as perfect cosmic vaults, preserving the ashes of dead stars in pristine condition. When we examine these tiny grains, we are literally holding pieces of other star systems, tiny fragments of a galactic history that predates the very existence of the Earth. Among the heavy metallic stones and ancient chondrites, researchers have uncovered a ghostly phenomenon that records the invisible forces of the primordial dawn. As these ancient rocks were slowly cooling and solidifying billions of years ago, they were bathed in a massive, swirling magnetic field generated by the young, hyperactive sun and the surrounding nebula. The metallic elements within the stones, particularly iron and nickel, aligned their internal structures with this invisible magnetic web, locking the magnetic direction into place as they froze solid. Today, when scientists measure these meteorites in the laboratory, they can detect this incredibly faint remnant magnetism, a frozen echo of a magnetic field that vanished billions of years ago. This delicate magnetic memory allows us to map the invisible currents of the early solar system, showing how magnetic forces helped clump the first dust grains together to build the planets. It proves that the stones of the asteroid belt are not merely physical remnants, but magnetic tape recorders that captured the invisible energies of creation. while the massive bodies like Ceres and Vesta spin with a smooth, predictable grace around a single axis. Many of the smaller fragments engage in a much more chaotic dance. Because they were born from violent, asymmetrical collisions, these jagged shards of rock often lack the balance required for a stable, uniform rotation. Instead of spinning like a perfect top, they undergo a complex movement known as non-principal axis rotation, tumbling wildly end over end as they drift through the void. If you were to stand on the surface of one of these tumbling stones, the stars would not trace simple arcs across the sky, but would loop and swirl in unpredictable, dizzying patterns. The sun would rise and set at irregular intervals, casting wild, sweeping shadows across the craters and dusty plains in a constantly shifting display of light. It is a mesmerizing, slow-motion freefall through eternity, where the smallest fragments of the belt move with a wild freedom, untouched by the stabilizing gravity of the giants. The incredibly fine dust born from the silent collisions we witnessed earlier does not remain floating in the main belt forever, but is subject to a relentless, invisible pull. This phenomenon, known as the pointing Robertson drag, occurs when microscopic dust grains absorb the energy of sunlight and emit it as thermal radiation in all directions. Because the dust grain is moving forward in its orbit, this emission creates a microscopic braking effect, slowly robbing the tiny particle of its forward momentum. Over tens of thousands of years, this incredibly subtle loss of speed causes the dust grain to lose its fight against gravity, forcing it into a slow, downward spiral toward the inner solar system. It is a constant, invisible rain of ancient asteroid dust falling gracefully toward the sun, crossing the orbits of Mars, Earth, and Venus along the way. This gentle solar braking ensures that the asteroid belt is constantly swept clean of its finest debris, feeding the inner system with a continuous stream of cosmic powder. The defining boundary between the dry, rocky inner asteroids and the ice-rich outer wanderers was not always fixed in its current position. In the early days of the solar system, the young sun was significantly cooler and dimmer than it is today, meaning the freezing threshold known as the snow line was located much closer to the inner planets. During this ancient epoch, vast quantities of water ice were able to comfortably form and survive on asteroids much closer to the sun, creating a belt that was predominantly frozen. As the sun gradually aged and burned brighter, this invisible wall of heat slowly expanded outward, pushing the snow line deeper into the asteroid belt and gently baking the ice from the surfaces of millions of stones. The dry, rocky asteroids we see in the inner belt today are the baked remnants of this solar awakening, stripped of their ancient frost by the rising warmth of our star. It is a grand, slow-moving climate change on a solar scale, where the expanding warmth of the sun continuously rewrites the chemistry of the wandering stones. humanity could not remain content with merely watching these shadows and listening to radar echoes from afar, driven by a deep desire to finally touch the ancient void. In recent years, brilliant engineers have launched robotic explorers designed to journey across millions of miles, perfectly match the chaotic tumble of a smaller asteroid, and reach out to make physical contact. These courageous probes, targeting small, near-Earth wanderers that originally escaped from the main belt, perform a delicate, dangerous dance to kiss the surface of the stones. They fire tiny projectiles into the ancient dust or release bursts of nitrogen gas, capturing the disturbed debris before firing their engines to escape the weak gravitational embrace. Returning these pristine grains to Earth in reinforced capsules allows scientists to hold the pure, unweathered essence of the asteroid belt in their hands for the very first time. It is a profound triumph of navigation and curiosity, bridging the vast, empty gulf between our dynamic blue world and the silent, frozen rocks of the deep dark. When one of these modern robotic explorers finally reached down to touch the surface of a dark, carbon-rich rubble pile, the asteroid revealed a shocking and beautiful secret. Scientists expected the spacecraft's sampling arm to strike a solid, unyielding surface of compacted dirt and stone. But instead, the probe sank deeply and effortlessly into the exterior. The weak gravity and high porosity of the asteroid meant that its surface behaved less like solid rock and more like a dry, loosely packed fluid of pebbles and dust. If the spacecraft had not immediately fired its thrusters to back away, it could have been completely swallowed by the shifting, flowing rocks of the asteroid's outer shell. This incredible encounter proved that many of these ancient wanderers are incredibly fragile and softly packed, held together by the absolute bare minimum of cosmic forces. They are floating optical illusions of solid stone, waiting to flow and yield at the slightest physical touch from an outside visitor. As we project our gaze deep into the unimaginable future, we realize that the quiet stability of the asteroid belt is not a permanent state, but a fleeting chapter in a much larger cosmic story. Roughly 5 billion years from now, our sun will exhaust its hydrogen fuel and begin to violently expand, transforming into a massive, glowing red giant that will swallow the inner planets. As the searing face of the dying star pushes outward, the incredible heat will finally reach the cold, icy reservoirs of the outer asteroid belt and the dwarf planet Ceres. The ancient ice locked within these dark stones will rapidly boil away, transforming millions of dormant asteroids into a spectacular, chaotic ring of glowing comets. For a brief, glorious period at the end of the solar system's life, the asteroid belt will awaken in a brilliant display of vapor and glowing tails, before the sun finally shrinks into a white dwarf and leaves the remaining dry husks to orbit in eternal night. It is a majestic, fiery destiny waiting patiently in the distant future, a final, beautiful transformation for the silent stones. As we continue to drift through this endless sea of quiet stones, we are reminded of humanity's deep desire to bring order to the dark. Whenever our robotic eyes confirm the stable orbit of a newly discovered wanderer, we bestow upon it a name, transforming a nameless rock into a recognized member of our cosmic family. In the early centuries of astronomy, these names were drawn exclusively from ancient mythology, honoring gods and goddesses of antiquity. Today, this sprawling ring has become a vast, floating memorial, with thousands of stones named in honor of poets, scientists, musicians, and even beloved friends. It is a beautiful thought that as we sleep, small fragments of our own history and culture are drifting silently through the deep freeze of space. They carry our terrestrial memories on an eternal journey around the sun, bridging the gap between human sentiment and the cold reality of the void. When we catalog the millions of inhabitants within this grand ring, we uncover a perfectly balanced, mathematical harmony governing their sizes. The distribution of matter in the asteroid belt follows a strict power law, meaning that for every massive body we find, there are dozens of medium-sized rocks and thousands of even smaller fragments. This creates a beautifully fractal landscape, where the pattern of brokenness repeats endlessly no matter how closely we look. It resembles the scattered remnants of a shattered pane of glass, where a few large shards sit among an uncountable sea of tiny, glittering splinters. This elegant mathematical balance proves that the destruction of ancient worlds was not entirely random, but followed the precise, unforgiving laws of physics. The universe breaks its creations with the same mathematical precision it uses to build them, leaving a perfectly proportioned hierarchy of stone. Although the very existence of these fragments points to a deeply violent and chaotic past, the modern asteroid belt is a place of profound, enduring peace. The turbulent era of planetary formation has long since passed, and the current environment is defined by incredibly vast, empty spaces where impacts are exceptionally rare. A major collision between two large asteroids is an event that now happens only once every few million years, a timescale that dwarfs the entire history of human existence. The rocks have found a steady, stable rhythm, having survived the dangerous gauntlet of their youth to enter a quiet, extended middle age. When we look at the battered craters on their surfaces, we are looking at ancient wounds that have not been touched for eons. They are the peaceful survivors of a forgotten war, floating calmly through a profoundly quiet era of the solar system. When those rare, microscopic impacts do occur from tiny grains of cosmic dust, the energy of the strike behaves in a fascinating way within the vacuum. Because there is no atmosphere to carry the sound of the impact away as a shockwave, the physical energy is driven entirely inward, deep into the heart of the stone. This creates slow, deep seismic vibrations that ripple through the interior of the asteroid, bouncing off internal voids and dense metallic cores. For hours after a tiny strike, a solid metallic or stony asteroid will vibrate in the dark, ringing like a deeply pitched, silent bell. The rock absorbs and dissipates the energy through pure, physical oscillation, a completely silent song of physics playing out in the dark. It is a mesmerizing concept that these floating mountains can hum and ring with internal motion, while the space immediately surrounding them remains perfectly still and soundless. As humanity looks forward to venturing deeper into the uncharted territories of the solar system, this quiet belt of stones takes on a completely new significance. The true treasure hidden within these wandering fragments is not the rare gold or platinum, but the ancient, frozen water locked within the dark carbon asteroids. In the future, these icy rocks could serve as vital, floating oases in the deep desert of space, providing the essential hydrogen and oxygen needed to fuel the next generation of spacecraft. Instead of hauling massive amounts of heavy fuel up from the gravity well of Earth, deep space explorers could harvest the ancient ice left behind by the solar nebula. The asteroid belt transforms from a barrier of dead rocks into a sprawling network of stepping stones, offering the sustenance needed to reach the distant, giant planets. The very fragments that failed to build a world may one day provide the foundation for humanity to explore the stars. The continued existence of this magnificent, scattered ring is a miracle of celestial mechanics, owed entirely to the gravitational influence of a distant, golden neighbor. When the massive planet Jupiter first began its destructive inward migration billions of years ago, it threatened to sweep the entire region completely clear of matter. However, just as Jupiter was poised to erase the asteroid belt forever, the powerful gravitational pull of the newly formed Saturn began to tug backward on the larger gas giant. This massive, invisible tether between the two titans halted Jupiter's inward march, eventually pulling it back out to the colder regions where it rests today. Without Saturn acting as a cosmic anchor, the beautiful sea of drifting stones we see now would have been entirely swallowed by the sun or cast out into the interstellar dark. We are indebted to the elegant, balancing dance of the outer giants for preserving this quiet sanctuary of ancient rubble. Even from hundreds of millions of miles away, the giant planets continue to exert a gentle, invisible influence over the daily lives of these wandering stones. These distant forces manifest as secular resonances, incredibly slow, sweeping waves of gravity that wash through the asteroid belt over periods of millions of years. Like the slow changing of ocean tides, these gravitational waves gently push and pull on the orbits of the asteroids, causing their paths to slowly tilt and wobble. This means the silent paths they trace around the sun are not perfectly fixed, but are constantly flexing and shifting in response to the massive, breathing architecture of the outer system. The asteroids act as tiny, sensitive buoys floating on an invisible sea, bobbing gently to the deep, harmonic rhythms played by Jupiter and Saturn. It is a slow, majestic choreography where every single piece of the solar system is continuously reacting to the weight of its neighbors. Occasionally, the familiar, steady rhythm of the main belt is interrupted by the fleeting passage of a ghost from another corner of the galaxy. Astronomers have recently discovered that strange, interstellar objects, cast out from alien star systems, glide silently through our solar system on highly unusual, open trajectories. These speeding phantoms, forged in the light of completely different suns, plunge through the plane of the asteroid belt before vanishing back into the deep interstellar dark. For a brief, silent moment, the ancient rocks of our own cosmic backyard share the same space with a wandering piece of deep galactic mystery. The belt serves as a quiet, temporary host to these speeding travelers, a place where local history momentarily intersects with the infinite expanse of the Milky Way. It reminds us that our solar system is not a sealed bubble, but a porous harbor open to the endless ocean of the universe. To understand and map this incredibly vast, shifting architecture, human ingenuity has built tireless, robotic eyes that never look away from the dark. Massive automated telescopes stationed on high mountain peaks around our world spend every night sweeping the sky, taking countless images of the deep void. Software gently compares these images, searching for the tiny, single pixels that shift their position against the fixed and eternal backdrop of the distant stars. These silent sentinels discover thousands of new drifting worlds every single month, slowly illuminating the dark pathways of the belt while the rest of humanity sleeps. They are the patient cartographers of the cosmic ocean, turning the terrifying emptiness of space into a beautifully mapped and understood neighborhood. Their steady, unblinking vigil ensures that the forgotten stones of the early solar system are finally seen and remembered. If we try to find the absolute physical boundary of this magnificent ring of stone, we discover a beautiful, philosophical truth about the architecture of space. The asteroid belt does not end with a sharp, definitive wall, nor is there a clear border where the rocks simply stop existing. Instead, the density of the floating fragments simply thins out gradually, becoming more and more sparse as we drift further outward into the freezing dark. It is a seamless, elegant gradient, gently fading away like a deep breath released slowly into the quiet night. The inner solar system does not abruptly end, but rather dissolves beautifully into the vast, empty domain of the outer gas giants. As we reach the outer fringes of this fading kingdom, we prepare to leave the realm of stone behind, carrying the silent peace of the wanderers with us into the deeper dark. As we cross the fading outer boundary of this magnificent ring, we find ourselves suspended in a profound transitional zone. Looking back toward the inner solar system, the rocky planets appear as distant, warm embers gathered closely around the bright hearth of the sun. Ahead of us lies the freezing, boundless domain of the giant gas planets, a completely different realm ruled by thick atmospheres and rings of ice. The asteroid belt stands exactly at the balance point of these two empires, a physical border constructed entirely of preserved cosmic memory. It is a quiet threshold where the fierce heat of the star finally loses its absolute grip, allowing the deep freeze of the outer void to take hold. By existing precisely in this middle ground, the wandering stones serve as a perfect bridge between the burning rocks of the inner system and the frozen giants of the dark. Hidden within the molecular structure of every drifting stone is a unique and permanent signature known as an isotopic fingerprint. Scientists analyzing fragments that fall to Earth measure the delicate ratios of oxygen and titanium atoms, discovering that each asteroid family carries its own distinct chemical barcode. These atomic signatures prove that the materials within the belt never completely melted together or mixed into a single, uniform mass. Instead, each individual rock has jealously guarded its original atomic identity since the very first moments of the solar nebula's collapse. This means the belt is not a homogeneous ring of debris, but a beautifully diverse mosaic of completely independent chemical histories floating side by side. It is a silent library of elements, where every stone is a unique volume written in the exact language of ancient atoms. Deep inside the metallic wanderers, the silent passage of immense time has carved beautiful, hidden geometries that are impossible to recreate on Earth. When the iron and nickel cores of shattered protoplanets were exposed to the cold vacuum of space, they did not freeze instantly, but rather cooled at an agonizingly slow pace. It took millions of years for the temperature inside these metallic stones to drop by just a single degree, allowing the metal atoms to arrange themselves into perfectly interlacing crystals. This incredibly slow, patient cooling created mesmerizing, cross-hatched metallic structures which remain locked inside the solid iron forever. We cannot force nature to build these elegant metallic crystals in our laboratories, for they require the vast, unbroken patience of deep space and deep time. They are the physical embodiment of eternity, grown slowly in the dark and hidden beneath layers of cosmic dust. To understand how these ancient bodies could melt and form these metallic cores so far from the young sun, we must look to a ghost of a radioactive past. When the solar system was born, it was heavily seeded with a powerful, fast-decaying radioactive isotope of aluminum, blown in by a nearby exploding star. For a few million years, this radioactive dust generated intense internal heat within the larger asteroids, melting their rocky interiors and allowing the heavy metals to sink to the center. However, this cosmic fuel burned out incredibly quickly on a geological timescale, leaving the stones to slowly freeze solid once more. The asteroid belt is essentially a graveyard of these briefly active worlds. Their internal fires extinguished billions of years ago when the radioactive embers finally died. They remain suspended in the dark, frozen exactly as they were the moment their ancient, internal heat finally faded away into the vacuum. Despite the staggering number of individual rocks and the vast amount of space they occupy, the overall mass of the entire belt exerts an incredibly delicate collective gravity. All the millions of fragments, when added together, possess only a tiny fraction of the mass of our own moon, making their gravitational pull on the rest of the solar system beautifully subtle. Yet, astronomers must carefully account for this faint, collective tug when calculating the precise orbits of the inner planets, particularly the shifting path of Mars. The combined presence of these scattered stones creates a very slight, constant gravitational drag that perfectly aligns with the most advanced theories of relativity. It is a wonderful realization that the smallest, most broken pieces of our solar system help scientists prove the grandest, most complex laws of physics. The invisible hum of their combined mass softly shapes the geometry of space itself, a gentle weight resting quietly on the fabric of the universe. Decades ago, when humanity first began launching delicate robotic probes toward the outer gas giants, there was a deep fear that crossing this ring of stone would be an impossible, destructive task. Scientists worried that the belt was a thick, impenetrable wall of grinding rocks and dust that would instantly crush any fragile machine attempting to pass through. Yet, as the courageous early spacecraft sailed silently into the belt, they encountered nothing but the profound, unbroken emptiness of the void. The probes coasted for months through the heart of the ring, without ever coming close to a single drifting stone, proving that the true nature of the belt is overwhelming, majestic isolation. This safe passage revealed that space is far larger and far emptier than our terrestrial minds could easily comprehend at the time. It confirmed that the asteroid belt is not a hazardous barrier, but an open, quiet ocean with millions of miles between each floating island. Even now, with all our advanced telescopic eyes sweeping the dark, the asteroid belt continues to hold onto deep secrets, hiding completely unknown wanderers in its most distant shadows. Because the stones are small and covered in dark, ancient carbon, they reflect almost no light, allowing thousands of substantial bodies to slip through our observational nets. It is highly likely that there are still massive, spherical asteroids, or even small dwarf planets resting quietly in the dense, unswept corners of the main belt, waiting patiently to be found. As we refine our infrared vision and stare longer into the deep, the darkness periodically yields a new, slow-moving point of light, adding another silent member to the ancient family. The belt is not a finished map, but an ongoing frontier of discovery, a vast attic of the solar system where forgotten treasures are still wrapped in shadows. It promises that the thrill of discovery will continue to pull us outward, searching for the quiet monuments we have yet to see. The incredibly fine dust that is constantly ground down by the gentle collisions of these stones serves a vital, invisible purpose for the entire inner solar system. As the solar wind streams outward from the sun at millions of miles per hour, it carries a harsh, continuous wave of charged particles and high-energy radiation. When this invisible solar storm crashes into the sprawling sea of asteroid dust, the tiny grains gently scatter and diffuse the intense energy, acting as a faint, cosmic filter. This delicate interaction between ancient rock dust and solar radiation creates a subtle, magnetic buffering zone that stretches across the middle of the solar system. The pulverized remains of broken worlds provide a soft, invisible shield, helping to calm the violent weather of the young star as it blows outward. It is a beautiful exchange of energy, where the smallest fragments of stone interact with the blinding power of the sun to shape the invisible environment of the void. As we drift among these peaceful, isolated stones, we are truly swimming through a beautifully fossilized era of cosmic dynamics. In the rest of the solar system, the planets continue to grow, their surfaces constantly rewritten by volcanoes, thick atmospheres, and flowing oceans, completely erasing the memories of their birth. But here, the massive gravitational disruption of Jupiter halted the clock entirely, freezing the environment at the exact moment of planetary infancy. Every crater, every loose rubble pile, and every metallic shard is a perfectly preserved snapshot of what the entire solar system looked like 4 billion years ago. The asteroid belt is the only place where we can directly observe the chaotic building blocks of creation exactly as they were left when the grand construction project was abandoned. It is the ultimate museum of the dawn, a place where the deep past is not buried underground, but floats freely in the open, endless night. Taking a moment to pause at the very edge of this sprawling, rocky kingdom, we turn our gaze back toward the center of the solar system. From this profound distance, the sun no longer commands the sky as a blinding, overwhelming fire, but has softened into a brilliantly bright, distant star against the black velvet. Its light is still strong enough to gently warm the dusty surfaces of the drifting stones, but its fierce heat has completely surrendered to the deep cold of the outer void. The millions of asteroids spread out around us catch this pale, distant light, sparkling like a vast, slow-moving river of faint diamonds circling the heart of the system. We have traveled through the entirety of this ancient, silent ring, witnessing the beautiful ruins of worlds that never came to be. Here, in the quiet margin between the light and the deep dark, the stones continue their eternal, rhythmic dance, perfectly content in their endless drift around the star. As our journey reaches its natural conclusion, we slowly drift away from the grand ring of stone, leaving the ancient wanderers to continue their eternal dance in the dark. We have traveled through billions of years of history, reading the story of our solar system written in dust, ice, and heavy metal. These scattered fragments are no longer just cold rocks floating in a vast emptiness, but profound monuments to the dawn of creation. They remind us that there is a delicate beauty in the broken, the unfinished, and the quiet spaces between the worlds. The asteroid belt stands as a testament to endurance, a silent kingdom that survived the violent birth of the sun and the chaotic migrations of the giant planets, finding its own perfect, enduring harmony in the deep freeze of space. Looking back one last time, the millions of individual stones merge into a single, faint ribbon of light, a gentle belt of dust reflecting the fading warmth of our star. The silence here is absolute, an unbreakable peace that wraps around every crater, every mountain of ice, and every tumbling shard of metal. While the planets of the inner system are locked in a constant cycle of weather, erosion, and restless change, the asteroid belt remains untouched by the frantic pace of evolution. It is a comforting realization that in a universe defined by constant motion and overwhelming forces, there exist places of such profound, unmoving stillness. The slow, steady rotation of the asteroids, measured not in fleeting days, but in vast, uncountable millennia, teaches us the quiet value of patience and the gentle passage of time. They ask nothing of the cosmos, content merely to exist, to hold onto their ancient memories in the deep cold, and to silently trace their long, elliptical orbits around the light that gave them shape. We carry the serene calm of this distant rocky realm back with us across the void, letting the vast, empty spaces of the solar system gently wash away the heavy weight of our waking lives. The very same ancient elements that make up the dark carbon stones and the heavy iron cores are woven intimately into the fabric of our own bodies, connecting us physically to this sprawling ring of memory. We are tethered to the same gentle gravity, moving together with these silent companions through the endless, dark ocean of the Milky Way galaxy. As the faint, sparkling light of the asteroid belt finally dissolves into the deep, velvet black of the outer solar system, the mind is free to untangle, drifting weightless in the comforting dark. We leave the stones to their endless watch, safely suspended in the magnificent architecture of the void. May the profound, empty silence of the cosmos bring you perfect tranquility, and may your rest be as deep, steady, and undisturbed as the ancient stones sleeping in the eternal night.